Okay, section 7.1, number 5. They give us y equals 3 times x cubed minus x and 0. And y equals 0 is a fancy way of saying the x-axis. Correct. So I think the area they want, and they give you this picture in the book, there's two little pieces. There's this piece right here, and then there's that piece right there. Maybe I'll try zooming in a little bit here, see if it comes out better. That's a better picture. So we want to find this area plus that area. What's that?
0.
Okay, except, again, remember when I talk about area, I'm saying I want this piece to be positive, and then we're also going to consider this piece to be positive, and we're going to add the two values together. You're right. If I were to simply integrate from -1 to 1 of this function, I would get 0. I agree completely, because this part and this part have the same size. This part would be positive, this part would be negative. But when I ask you to find the area bounded by the curve, I want you to consider everything having absolute value, so everything being positive. How do I find the area? I could add the two integrals together. That would work fine. Or what would be my other option? Could do absolute value of the whole thing. That would work. I was thinking of yet another option. I could use my calculator. Well, what if I do that? Calculate the integral. It will give me 0. Because it considers this area to be negative.
Could you just do the left side and multiply it by 2?
I could do the left side and multiply it by 2, or I could do the right side and multiply it by 2. Whichever one we think is easier. So I think that's what I would do. If I were finding the area, I think my answer would be, I would do the integral from -1 to 0 of 3 times x cubed minus x dx, and then double that answer. And that only works because the graph that we have is an odd graph. It's nice and symmetric. If it were not symmetric, we wouldn't be able to just double. We'd actually have to find each piece and then add them together. Okay, so I think that's how I would find it. I think that's probably the easiest way. Questions on that?
What makes the graph non-symmetric?
What would make the graph non-symmetric?
Like, is there a way you can do it without having to look at the graph?
Yes. On this graph, I notice all the exponents are odd, which tells me this is an odd function, which tells me it's going to be symmetric. Symmetric, this is called a rotational symmetry. If I turn my calculator upside down, I still have exactly the same picture. So if all the exponents are odd, you have a kind of symmetry, a rotational symmetry. If all the exponents are even, you also have a kind of symmetry. What kind of symmetry do you have when all the exponents are even? A reflective symmetry. So if this were x to the 4th, and that one were x squared, I have a reflective symmetry. What do we mean by reflective symmetry? Yeah, it's like a mirror image. If I could cut my calculator screen right on the axis and flip it over, it would match perfectly. So again, if this were the problem, I could again simply do half of it and double. Symmetry doesn't happen all that often, though. Most of the times, functions are not symmetric, because most of the time you don't have all even exponents, or you don't have all odd exponents. Usually they're mixed together. Other questions? All right, I wanted to do one problem out of the book here. X equals 4 minus y squared, and x equals y minus 2. What does the graph of x equal 4 minus y squared look like? Close. So what you could do is, I think what you're doing is you're writing this as x equals 4 minus y squared. You could write this as y squared equals 4 minus x. Well, what I did is I added y squared to both sides, and I subtracted x, because I wanted it to be a positive y squared. And then what happens when I take square root? I got to remember there are two of them. There's a positive square root and a negative square root. So I get y equals plus and minus the square root of 4 minus x. So y equals square root of 4 minus x. And y equals negative square root of 4 minus x. Well, I need to change my window a little bit, but what's it going to look like? It's a sideways parabola. Why is it a sideways parabola?
Because each one's identical, but one's not even
Okay. Or, back from the original equation, if you have a y, but you have an x squared, then it's a parabola that goes up or down. Conversely, if you have an x and a y squared, it's going to be a parabola that goes left or right. In this case, it goes left. How did I know right away that this parabola was going to go left? The y squared was negative. All right, so this is a parabola. Opens to the left, like so. What does x equal y minus 2 look like? That's a line. Y equals x plus 2. Looks like that. And they meet right there, and they meet down there somewhere. All right, so I want to find this area. The area in between all those graphs. What do I do? What do you mean? Okay, so you're saying that what I should do is split it right here and find this area on the left and this area on the right. Okay, and why do you say I should do that?
So that you're dealing with two functions rather than three.
Okay, very good. The problem is, when I'm over here, and again, think about how we built little rectangles in the past. If I built little rectangles, I'm going to have the line on top, and I would have what on bottom? The negative square root on bottom. Unfortunately, once I get past the axis, what do I have on top? The positive square root, and what do I have on bottom? The negative square root. So as I move along here, the thing on top changes. What that tells me is I'm going to need multiple integrals. Okay? So the answer is, area is the integral. Okay, what's the function on top here? The function on top is the line, which is x plus 2, minus, what was the function on bottom? The negative square root. So I'm going to have minus a negative. That's going to make it a plus, isn't it? Plus square root of 4 minus x dx. And what are my numbers? What number on bottom, what number on top? All right, what I would do, I would use my calculator, I would do the intersect. And this is where the calculator asks you, is this the first curve, is this the second curve? Because we have 3 equations typed in, we need to make sure we use the right 2. If I'm trying to find this point down here, I want to use the negative square root in the line. But right now, if I look here, I'm on the positive square root. So is that the first curve? Is that the one I want to use? No. So this is why the calculator asks that question. And a lot of students always ask me about that in an algebra class. In an algebra class, we almost only ever have two equations. So that first curve, second curve question doesn't make sense to them. So there's the line. There's the negative square root. That's the one I want. So there's the first curve. And that's the second curve is the line. That's good. And then I want the point down over here. And that point is -5, -3. So for the left-hand region, x goes from -5 up to 0, correct? This point right here has x equals 0. Okay. Plus, now I need the second integral. The second integral is going to go from, I think that's the point 4, 0 right there. So that's going to go from 0 to 4. What's the function on top? The positive square root minus, what's the function on bottom? The negative square root, negative and negative becomes a plus again. And there's my formula for area.
Can't we always just say 2 guys, whatever it is?
Absolutely. This one you could simplify it. You could write it as 2 square root of 4 minus x. Absolutely.
Because I notice that happens every time, no matter if it's even or not.
That's going to happen. Yep. If it's a square root. Now, here's the pain in the neck. What if I wanted you to actually evaluate this integral and give me a number? How do you integrate x? It's a trick question. It's real easy. What's the antiderivative of x? 1/2 x squared. What's the antiderivative of 2? 2x. What's the antiderivative of square root of 4 minus x? A pain in the neck because you have to use u substitution because you have a square root and you have something more than just x underneath that square root. So in order to find this antiderivative and this one over here, you're going to need u substitution. That's kind of a pain in the neck. I've got good news. There's a better way to do this problem. No, I will ask you to do this problem. We just did this problem the very hard way. There's a much easier way. And the much easier way is, consider what would happen instead of building our rectangles up and down, what if we built our rectangles left and right? What would be different? Well, the main thing that would be different is we wouldn't have dx. We would have dy. Because remember, dx stood for the width of each rectangle. If I'm building this way, then the width of each rectangle would be how tall each rectangle is, and that would be dy. So another way to do this one is area is going to be integral dy. So the things we're going to write here, these are all going to be functions involving the letter y, not the letter x.
So we're just using our original one that we were given, like 4 minus y squared and y minus 2.
Exactly. Because look, no matter where I build a horizontal rectangle, no matter where I build it, what's on the right? On the right, this is the right. The parabola is always on the right. And if I'm dealing with y's, the parabola is only one equation, isn't it? 4 minus y squared. So I always have the parabola on the right, and I always have the line on the left. So I do the big one minus the small one. Big minus small means right minus left when you're dealing with y's. So this would be 4 minus y squared, that's the thing on the right, minus the thing on the left is the line, which is y minus 2.
And the question is, what's the area of the integral?
What do you mean, what's the area of the integral?
The range of the integral.
Oh, what's the range? Okay.
Because I know it's -5, but do we know the top one? Wouldn't it be like the top one?
Okay, so now we're using y's. So our values would be the smallest y number. What's the smallest y number?
Oh, okay. So
-3 is the smallest y number. Got to use y's, always y's here.
Okay.
And what's the biggest x number? Where did those cross right there? 0, 2. So we use the y numbers, not the x numbers.
I figured it was that. I just didn't know which. So it's always lower.
You're still going to have, because you have 1, 7,
Nope, the fact that I subtracted will take care of it. So, like down here, this is going to be a positive minus a negative will still be a positive number. The subtraction takes care of the fact if it's above or below or left or right of the axes. You don't have to worry about that. So, which one's easier? The second one would be much easier. It'd be much easier to find the antiderivative and plug the numbers in. Okay? Questions about that? Can you do it both ways?
Yes.
Absolutely. But sometimes one way is easier than the other. How in general are you going to know if using dy is your better choice? Or when the original equations are given in this form. When the original equations are solved for x equals, it's almost always going to be easier to go dy. If the original equations are solved for y equals, it'll almost always be easier to use dx.
What if you're looking at an ellipse?
What if you're looking at an ellipse? There is a formula for area of an ellipse. If we had an ellipse, unfortunately, in order to actually do the antiderivative, you would need something called substitution by trig functions. So you'll do that in Calc 2. We could set up the answer, but we wouldn't be able to evaluate it at this point.
Why not?
Because we don't know integration by trig substitution.
You have to just find the area of 1/2 of the ellipse or something like that?
Yes, but even to do that, you would need integration by trig substitution. Now, there is a formula. You could look up the formula for area of an ellipse. There is a formula for it. But the formula was originally derived using calculus. So it's chicken or the egg kind of question.